Never before has a man-made object ventured so close to the sun. The Parker Solar Probe is on an extraordinary mission, providing us with unprecedented data about our star. However, amidst all the excitement surrounding this groundbreaking project, one burning question captures the public's imagination. Why doesn't the probe melt when it's near the sun? The Parker Solar Probe periodically traverses the sun's hottest layer, not the surface, but the corona. This outer atmosphere of the sun is where temperatures can reach up to 1 million degrees Celsius, far hotter than the sun's surface, which is around 6,000 degrees Celsius. In this video, we'll uncover how the probe survives these extreme conditions and what revolutionary insights it promises to deliver. Before we dive in, we'd like to remind you to contribute to our channel by leaving a comment related to the topic at the end. We'll reward your insightful contributions with a heart and pin the most enriching comment to the top for everyone to see. Just be sure to subscribe to our channel, like this video, and mention both in your comment. Exploring the sun is of immense importance to us Earthlings. Without the sun, life on our planet would be impossible. Our climate, seasons, and even the magnetic field that shields our planet from cosmic radiation are all influenced by the sun. Some even believe that solar storms have subtle but significant effects on the human psyche, similar to the full moon. From a scientific perspective, understanding the sun's surface and corona is vital for unlocking its many mysteries. The corona, named after the Latin word for wreath, is the thin, glowing halo that surrounds the sun. It is usually visible only with special filters or during a solar eclipse. Despite decades of study, this layer remains an enigma. How can a region located far above the sun's surface be so much hotter? Scientists suspect the answer lies in physical forces and chemical processes we do not yet understand. The Parker Solar Probe's mission is to unravel these mysteries. One intriguing possibility is that insights from the probe could even influence our energy industry. For example, if we could replicate the mechanisms the sun uses to generate such intense heat, we might revolutionize energy production, making it more efficient and environmentally friendly. Beyond studying heat, the probe is also investigating solar storms, gigantic eruptions of plasma and charged particles. These solar winds, driven by powerful eruptions on the sun's surface, can eventually escape the sun's gravity and travel through space. When these particle streams collide with Earth's magnetic field, they can distort it, potentially causing widespread electrical disruptions. The sun's behavior follows an 11-year cycle of activity, but in recent years, it has displayed unexpected fluctuations. First, solar activity weakened significantly, worrying scientists, only to surge again in unprecedented ways. These anomalies emphasize the need for missions like the Parker Solar Probe. Launched in August 2018, the Parker Solar Probe is a collaboration between NASA, the European Space Agency, and several other partners. The launch took advantage of a precise alignment between the Sun and Earth, enabling the probe to use the gravitational pull of Venus for a series of flybys before setting its course toward the Sun. During these flybys, scientists also gathered valuable data about Venus. In April 2021, the probe achieved a historic milestone by flying through the Sun's corona for the first time. Despite encountering temperatures of 2,500 degrees Celsius, the probe's instruments remained at a safe 30 degrees. This remarkable feat was made possible by its cutting-edge thermal protection system, which took nearly a decade to design and build. The thermal shield consists of 2 layers of carbon fiber reinforced carbon, which retains its structural integrity even at extreme temperatures. Between these layers is a carbon foam that minimizes heat transfer. The probe's exterior is coated in white aluminum oxide, which reflects much of the sun's heat, and a layer of tungsten, a dense metal with an extraordinarily high boiling point of 5,900 degrees Celsius, adds an extra barrier. Together, these materials ensure the probe's survival in the sun's harsh environment. To maintain its trajectory and protect its sensitive instruments, the probe's orientation is carefully programmed to keep its shield facing the sun. Cameras and sensors are strategically placed to peek out from behind the shield, allowing the probe to gather data without overheating. Additionally, the The probe spends only brief periods in the corona, minimizing its exposure to intense heat. This is akin to reaching into a hot oven for a moment without touching anything. As long as the duration is short, the heat remains manageable. During its first pass through the corona, the Parker Solar Probe reached speeds of 586,000 kilometers per hour, capturing valuable data and images before retreating to safer distances. Over the course of its mission, the probe will make several additional flybys of the Sun, with the closest scheduled for December 2024. The mission is expected to conclude in July 2025, though it could be extended if the probe remains functional. Even within the planned timeline, the Parker Solar Probe is set to revolutionize our understanding of the Sun. It will reveal the dynamics of solar winds, the processes behind the Sun's heat cycles, and much more. This knowledge will not only deepen our understanding of the universe, but also help protect our planet from the potentially catastrophic effects of solar storms. The probe is named after Eugene Parker, the scientist who first theorized the existence of solar winds. His pioneering work laid the foundation for modern solar research, making this mission a fitting tribute to his legacy. Here at the Curiosity Lab, we'll continue to keep you updated on the Parker Solar Probe's incredible journey. Now we want to hear from you. What are your thoughts on the probe's groundbreaking design and mission? Do you find it inspiring, or do you see it as just another technological achievement? Let us know in the comments. Don't forget to mention your subscription and like the video to ensure your comment stands out. Thank you for joining us today, and we look forward to seeing you next time.